In certain cases, constant vigilance is required, necessitating the constant checking and recording of data. In order to ensure accurate record-keeping, individuals in the laboratory are required to manually record readings from certain machines, since they do not automatically preserve data. Additionally, there are locations where it is not easy to measure temperature due to regulations prohibiting the use of electrical signals or signal interference. When electrical sensors aren't an option, there are alternative ways to get an accurate reading of the temperature. Fortunately, real-time temperature monitoring is already a thing. We are unable to log in, and the temperature sensor that uses light in the second current solution is not automated. Instead, it is handled manually. As a temperature sensor, FBG provides accurate readings in the current solution, albeit not many items actually use this technology. Much of the research is still limited to Arduino, which prevents us from uploading data to the cloud for real-time monitoring, analysis, and logging. They are merely demonstrating that the wavelength shifting is proportional to the temperature. What is the advantages of using FBG sensor compared to other? 1. Real-time monitoring. The system can monitor and display sensor readings in real time through the website dashboard. 2. Remote accessibility. Users can access the dashboard anywhere using a laptop or smartphone with an internet connection. 3. Automatic data visualization. Sensor data is automatically displayed in graphs and charts for easier monitoring and analysis. How do we begin to establish rapport? The ideal solution would be an optical temperature sensor that can be automatically and in real time monitored with a user interface through the use of a basic optical spectrum analyzer, or OSA for short. What is OSA? OSA is a device used in telecommunications and fiber optics to measure light wavelengths that has a communication port. This communication port is used for receiving commands, sending data, and configuring devices. So, what communication protocol does OSA use? OSA typically uses standard query data, standard data formats, and standard device configurations. This command is consistent, but it may vary slightly for different OSAs. As a result, the solution we provide will be compatible with a wide range of OSAs because OSAs employ a common communication method to obtain documentation from vendors. Then we can use Python to request data from OSA to our PC. Python programming language can be utilized towards USB port interface on the computer, where it can automate a number of activities, such as sending and reading data that travels through the USB port. This allows us to write code to automate the queries by connecting the port to the laptop and pulling data into Excel. But isn't it pretty hard and expensive? No problems. We have Raspberry Pi, which can run Python and has a Wi-Fi card for internet connectivity. But how to do it? Connect OSA to the Raspberry Pi USB port and use the same Python code to automate login and push data to the internet over Wi-Fi. And how are we going to store our data logging that is free? Google Sheet. We can use Google Sheet by Code Inside Apps script, which as a result automates data logging from IoT devices into the cloud. What about user interface website development? Vercel. Vercel provides a wide range of web-based solutions for free. A simple app should not incur any costs. In recent years, AI technology has evolved tremendously, notably in web programming. Vercel now offers v0.dev and ChatGPT. Then HTTP protocols understanding HTTP will enable us to utilize the way how data is transported. HTTP operates on top of TPIP, meaning each time it sends data. HTTP method has two types, HTTP/SLOST, and the second is HTTP/GET. Data from a server use HTTPG. It's perfect for getting resources from APIS, including HTML pages, pictures, or data. This is the results, our finding.
This is FBG temperature sensor system. FBG sends continuously the temperature change, and the temperature variation is believed on the OSA. OSA will transfer to our handphone wirelessly using the Raspberry Pi. So we can use continuously to check on the handphone.